Alright, Facebook peeps, hacksters, whatever you are. So last night we caught the amazing MegaBots battle against Sudobashi Heavy Industries. It was Iron Glory and Eagle Prime, the MegaBots robots from America, against the Karatas unit from Sudobashi in Japan. It was super cool. If you didn't catch it, I'm not going to spoil it for you. Go check it out on Twitch and yeah, have a good time. In the meantime, I'm really excited about robots. So this badge here is called the RoboBadge, and it's from Waterot Electronics. And what it does by default is it's programmed to work as a TV Begon, that thing that Mitch Altman sells as a kit, which is pretty exciting. The cool thing about this is that it actually works as a tiny robot battle. If you consider a TV a robot, then you're able to turn those off and disable them via infrared LEDs. Anyway, it's a bit of a stretch, but we're gonna put it together and it's gonna be awesome. They have a sweet GitHub repo with all the info about it. Wait, I think it's on the back of the badge. But I saw, oh yeah, here we go. github.com/waterot/RoboBadge, or Vatarot, I'm not sure how you say it. And I'm just going to go off this image that I have pulled up here because I think it's going to be pretty straightforward. As you can see, they've got these lines to indicate the ground wires on the LEDs. You got 4 resistors that are they're all the same, so it should be pretty easy to place those. And then you've got the colored LEDs, which are easy to tell, and the switches are both the same. So this should be basically a cinch, and having said that, I'm going to screw up horribly and it's going to be hilarious, so stick around. Let's start out with the infrared LEDs in the middle. No, actually, okay, best practice is to start with the lowest profile objects first, because then you can sort of flip it over and like put it down on your table and solder stuff without worrying about it. So maybe I'll do the resistors first. I mean, there's already this huge battery holder on here for a coin cell, but I'm gonna do it the right way. Fancy that. So let's see how much spacing these need. Okay, I'm gonna bend the leads so that they fit well in those little slots. Yeah, one interesting thing about this robot fight, right, was that I've actually been in a sumo bots competition before. Sumo bots are a pretty popular way of getting into electronics as a beginner, because basically you make a robot that's a glorified pair of wheels, but on top of that you can build pretty much anything you want, and the goal is to shove each other off of the playing field, which was one of the criteria for the battle last night. Actually, it took place I think last week sometime, but they've been holding out on us and just broadcast it on Twitch. So yeah, restrictions, combat. Yeah, so the way that they could win in this robot fight was by disabling the other robot, by knocking the other robot over, or by the pilot surrendering, which was an important option that they'd be able to tap out. In the live Q&A after the fact, they also mentioned that they were not allowed to use, for example, a giant spray gun full of salt water, which would have easily disabled the other robots' control systems. Likewise, they were not allowed to have giant gouts of flame coming out of guns, which would have been awesome to watch, but also would have made it a pretty short fight and been quite dangerous for the pilots involved. Unfortunately, I can tell you, this happens in the small leagues as well. I was not allowed to put a saltwater cannon on my tiny sumo bot. I was told first that there were no rules, and then they put all these restrictions, like no flamethrowers. What's with that? Anyway, it's true. They tend to not make for very entertaining fights for the people who are watching, but I think they make it a little cooler for those of us who like giant gouts of flame. Anyway, so yeah, it made me feel a little bit of kinship with them to know that we have the same thing going on. So if that's what you were going to tune in for, you know, giant flame things and saltwater cannons, then you're out of luck, unfortunately. I've bent out the leads on these resistors as usual so that they will stay in the holes as I flip it upside down and solder. And as always, I'm trying to get good adherence to both, or adhesion to both the pad on here, the solder pad, and the leg, which is how you get these sort of really nice, pretty, ideally concave, yeah, whatever, solder joints that end up sticking very well, as you can see, to both the pad and the leg. You've got this smooth transition. Nothing looks like it's sort of stuck in there. I'm going to go ahead and clip off my leads. Where did my side cutters go? Just do this as we go, holding on to these a little bit so that they don't just, like, you know, fly all over the place. Yeah, robot fights. I really wish I could just give a complete run through of how it went down, but I want to give you some time to go watch it yourself first. It was amazing! If you've been following it all, then you already know that there is a chainsaw sword arm thing involved, and that was a lot of fun to watch. That was really cool. So you won't be disappointed. That does come into play. I won't say any more. This is really hard to not talk about it. Let's see. Here we go. Flat side of the LED is the same as, if you can see that right here, it's reflecting off the flat side. And that's the same as the short leg, i.e. the ground side of the LED. Got to make sure you put your LEDs in the right way and in the right holes. According to the diagram there, this is where the infrared LEDs go in the middle. Oh, I was going to do the switches first, wasn't I? Well, let's do that. So switches are a bit of a pain sometimes if you're not working with an actual PCB. I actually was, here's a sneak peek at something else I'm working on to help me do better videos. Switches can be fickle. They can either be connected, these two legs are connected the same, or they're connected that way across. And it's hard to tell, so sometimes you just have to dig out the multimeter. Here's a better view of that, you know. In this case, the legs across from each other are connected. And then the other pair is disconnected from them unless you push the button, in which case all the legs are connected together. So in this case, since it's an existing PCB, I don't have to worry about which way they get hooked up. So I don't have to dig out the multimeter, but that is a challenge and a half, let me tell you. It's a little annoying. I wish they just had some kind of, like, you know, default labeling system. So these are tactile switches, aka little push buttons, and they're labeled RST and SW, which obviously means reset and switch. Some kind of user-controlled button, reset button. This whole thing is controlled by an ATtiny841, a low-power version of the ATtiny chip that can be programmed with Arduino code. So let's get these switches soldered on, and we'll get to try this out pretty soon. We don't actually have a TV in the office, which makes me very happy. But I'm also glad that nobody switched off the TV while we were watching Giant Robots last night. Did I mention there was a giant robot fight last night? I think that both teams had some pretty great sportsmanship, actually, sportspersonship. Yeah, the guy from Sudobashi in particular just seemed like he was having an awesome time. And I really appreciated that at one point he was asked how he felt during a particular moment when things had been going well for him. And I thought it was really interesting. He said that it was terrifying, but it felt amazing. Like his heart felt like he felt like he was going to have a heart attack. And that's so cool that he's able to, like, admit that, yes, it's awesome fighting giant robots. It's also terrifying. Like, if I were in that pilot seat, I'd be scared stiff as well. Okay, so we've got the resistors and switches on here. Now we just got 4 LEDs to hook up. Green one, red one, and 2 infrareds. Those will serve as the transmitters for this universal remote. Also, the whole thing works as a breakout for the ATtiny chip, which is pretty cool. As you can see, you've got the chip down here. Is that actually the ATtiny? Yeah, it is. So small. But yeah, you have lots of access to ground and power. You got a pair here, a pair here, a pair here, and a pair there. which, you know, is almost excessive. It's awesome. Your micro USB hookup down here, and then you've got your pin breakouts over here. So let's get these LEDs on, huh? All right. Again, the ground side goes inward towards the center of the PCB. Again, bending the legs outward underneath so that it stays in place. And we get this like really nice flush mounting against the surface of the PCB. I sometimes wonder if I sound like I'm doing a cooking show. Do I sound like a cooking show? Or what? What does this remind you of? Fortunately, we don't have to stick this in the oven for like 80 minutes and then pull out another one that you know was made before. And there's no commercial breaks. How about that? Okay, cool. Last round of soldering here. We'll go from this end for no particular reason. Yeah, as usual, I'm trying to contact the leg and the pad with the soldering iron and then bring the solder wire in from the other side. I've got two legs kind of soldered together here, but that doesn't matter because I'm going to cut them off. And what that does is make sure that I have good thermal contact with everything, so everything adheres very well and we get good connections. Yeah. Besides that, it doesn't really matter what order you solder things in. Of course, we are soldering this without power supplied to the board. General best practice. And so that means that, yeah, it doesn't matter how we hook things up. There are some things like, if you're working with NeoPixels, for example, not soldering, but like plugging things in, you want to make sure that you plug in the ground wires first and stuff like that. So if you're messing around with electronics, it's good to have your order of operations down. Let's switch off this soldering iron. Oh yeah, so we don't actually have a TV in the office, as I was saying, so we can't test this here. But we're about to go to lunch, and so I'm gonna see if I can find a place to practice with this. I might get kicked out of someplace. I don't know. We'll find out. And yeah. And give you an update. I'll probably put it on Twitter or Instagram Live or something, and just post you guys a link to it here. Oh yeah, so that's our finished RoboBadge. A little robot built to fight other robots. I mean, depending on your definition of robot. Some people think that robot only means something with moving parts, or that like it does work for you. The original word comes from a Slavic language. In Russian, for example, I don't think it's from Russian originally, but in Russian, rabota means work, and so robot is a worker, basically. Yeah, a lot of people think that a robot is by necessity something that moves or does a task for you, or both, and this doesn't really move, except for if you count these little buttons, which I don't. But neither does the TV, but I kind of like the idea that it's a tiny little robot fight in your hand, right? I don't know, it's cool. Plus it looks kind of badass. I'm gonna stick the coin cell battery in here. Yeah, you've got this plus sign over here, which indicates that, oh, you can't really see that, can you? Ooh, there we go. That contact is positive. And that's always the case with CR2032 coin cell batteries, your common little coin cell, is that the big smooth side is going to be the plus, the other side is going to be the minus, and that means that the outer rim is also positive. So you've got this side contact here, and this bottom contact means you're going to put it in like this. There we go. I've seen these holders getting a lot more popular lately, and I'm not sure why, because they're really a pain to get the coin cell out. Which, as long as you want it in there, is a good thing, but, like, I don't know. So we've got an on-off switch. What happens when I turn it on? Nothing! Huh. I hope I did it right. I'm gonna go have a look at the tutorial. My assumption is that I've done this correctly. However, it's possible that I missed something. The other thing that we can do is plug it into the computer with a micro USB cable or a charger. Here we go. Into the charger is a little safer because I don't want to mess up my computer, especially while I'm broadcasting. Okay, let's see. Oh! Okay, I plugged it in and it's doing this. Cool. I don't know what that means. I'm gonna have a look at the site real quick. Let's put it here so you can see the non-conductive one. So github.com/waterot/RoboBadge. There's a README. This is, I believe, where it said that it was automatically set up to be a TV beacon. However, that may not be the case. They have some software examples. They have assembly instructions. Fancy that. Resistors in place. Side cutters. Switches in place. LEDs in place. Yep. Also, this is in German. Cool. So if you speak German, you can read the little soldering tips. Lötkolben muss das Beinchen des Bauteils und... I'm not gonna try that. Okay, well, it looks like I did everything right. So my assumption is that either it's running something that's a little bit opaque, or I still need to program it. And they have their own package of boards that you can add in your Arduino boards manager to accomplish that. All right, so we're gonna go test this out over lunch. Which, I mean, I'm gonna probably get kicked out of some place. It'll be great.
Yeah, the remotes are broken.
I wasn't even paying attention.
Oh. Sorry, guys. It's in the name of science. It'll come back in just a second. Believe in the magic. Come on.
Do you believe in magic?
Do you believe? Are you believers? There we go.
What's the next line? I have no idea.
And you know it's true.
Cool.
Isn't it in a young girl's heart or something?